Assalamualaikum warahmatullahi ta'ala wabarakatuh, and hi again. In this lecture video, we want to look at topic 4.4, integration by substitution. The idea of integration by substitution is to transform a difficult integral to a simple integral by using a substitution. Remember, the key thing is we want to transform a difficult integral to a simple integral by using a substitution. Let f, g, and u be differentiable functions of x such that fx is equals to gu times du over dx. Then, integration fx dx, it is equals to integration gu du over dx times dx. And if you see here, we can simplify this to get integration gu du equals to capital Gu plus c. Where your final answer, because you change the integration problem in terms of x to in terms of u, then you'll get your result in terms of u. But later you'll see that your final answer, you need to transform it back to in terms of x. So basically, there are 6 basic procedures that you have to follow in order to perform integration by substitution. First, you need to choose a new variable u, and we let u equals to fx. And then, second, differentiate u with respect to x. In this case, you want to find du dx, which is equals to f prime x. Third, determine the value of dx, where dx is equals to du over f prime x. Fourth, make the substitution u equals to fx and dx equals to du over f prime x. Fifth, evaluate the resulting integral by using the basic formula of integration. Sixth, return to the initial variable, and in this case, you want to give your answer in terms of x. Let us look example given in your lecture slide. Evaluate integration 5x plus 3 power of 7 dx. If you see here, we have 5x plus 3 power of 7 dx. It is possible for you to expand this, but it will be very difficult because power of 7. So it is much easier if we use integration technique, which in this case is the substitution technique. So let us let u equals to 5x plus 3. And then we find du dx, where du dx is equals to 5. Then you'll find that dx is equals to du over 5. And then we will rewrite integration 5x plus 3 power of 7 dx, where we know just now that 5x plus 3 is u. Therefore, we can rewritten it so that it become integration u power of 7, and dx, we know that it is du over 5. So we will substitute it, and then we get integration u power of 7 du over 5. And at this stage, we have the integration problem is now in terms of u, and it is a simple integral where you can differentiate by using the basic formula of integration. So from here, then we get u power 1 over 40, integration 1 over 5 times u power of 7 du, it is equals to 1 over 40 times u power of 8 plus c. Okay, don't forget the constancy whenever you whenever you give the result of your integral. Okay, and then finally, you will rewrite this in terms of x. Okay, we want to go back to the original variable of the function, where in this case, it is in terms of x. So we know just now that u is equals to 5x plus 3. So we substitute u equals to 5x plus 3. Therefore, we get the final answer is 1 over 40 times 5x plus 3 power of 8 plus c. Okay, now let us look past year question. In particular, we want to look at the final exam question for semester 1, 2019-2020, question number 5. Evaluate the following integral using the substitution technique. Okay, for question A, we have integration 2x times square root 1 plus x squared dx. Okay, we want to let u equals to 1 plus x squared. Remember, the objective of using integration by substitution is we want to transform a difficult integral to a simple integral. If you see here, this is not this function, you cannot expand it and you cannot just rewrite it as usual. So what we have to do, we need to use the integration technique, and in this case it is the substitution technique, where we will substitute u equals to 1 plus we will substitute 1 plus x squared with u. So the integration, before that we will differentiate first u with respect to x. So find du dx, where du dx is 2x. And then the third procedure, we want to find what is dx, where dx is equals to du over 2x. So now the integration 2x times square root 1 plus x squared dx, it is equals to integration. We want to rewrite this because we want to get simple integral. Okay, we know that 1 plus x squared is u. So we will substitute square root u, and we know that dx is du over 2x. Therefore here du over 2x. And from here we get, okay, in order to know whether your substitution is correct or not, you must make sure that in the end you'll get your integral is in terms of u only, so that you can integrate it. You cannot have it in a mixture of variables. And in this case, if you see here, we can cancel out 2x. So what's left is integration u power of 1 over 2 du. Okay, now we have our integral is in terms of u only, and this is differentiable easily, where we will use this formula, integration x power of n dx, it is equals to x power of n plus 1 over n plus 1 plus c. Okay, this formula can be obtained from your formula book, but this is a very basic formula of integration, and this is equals to u power of 1 over 2 plus 1 over 1 over 2 plus 1 plus c. Don't forget plus c, where this is equals to u power of 3 over 2 over 3 over 2 plus c. And remember, our final answer, we don't want fraction in fraction. Okay, so we will rewrite this as it is equals to 2 over 3 u power of 3 over 2 plus c. And remember, your final answer must be also in terms of x, because we want to go back to the original variable of the integral, which is x. So we know that u it is equals to 1 plus x squared. So from there, we will substitute u with 1 plus x squared. So 2 over 3 1 plus x squared power of 3 over 2 plus c. So this is our final answer for question A. Next, let us look question B. Okay, for question B, we have a function involving trigonometry. Okay, solution for question B. Okay, for question B, we want to let u equals to 5 plus sine x. Okay. And when we choose u equals to 5 plus sine x, then du dx will be cos x. Okay, if you see here, when we choose u equals to 5 plus sine x, and then you get cos x, where cos x is here. Okay. So whenever you differentiate it, the differentiation result must be a part of the integration function, where in this case, it is cos x. So we know it gives a hint that our choice is most probably correct, okay? But we have to see later whether you'll get your integral in terms of u only. If you're able to do that, that's mean the integration, the substitution that you choose is correct. Okay, so let us continue. Okay, from there, then we know that we want to find du, where du is dx, not du. We want to find dx, where dx is du over cos x. Okay, so integration cos x over 5 plus sine x square dx, it is equal to, okay, we know that 5 plus sine x, okay, we know that 5 plus sine x is u. Therefore, this is equals to integration cos x over u square. And then we know that dx is equals to du over cos x. So du over cos x. And we can simplify this by cancel out the cos x. So from there we get it is equals to integration 1 over u square du. Okay, we not yet perform the integration. We just rewrite the function from a difficult integral to a simple integral. And if you see here, 1 over u square is, this function can be integrated easily, where we will use this formula as what we have in question A just now, where integration of x power of n dx, it is equals to x power of n plus 1 over n plus 1 plus c. Okay. So here we can rewritten this as u power of negative 2 du. Okay. If you see here, starting from here, we already have the integral in terms of u. So now it is possible for you to perform the integration, where by using this formula. So u power of negative 2 plus 1 is negative 1 over negative 1 plus c, where this is negative 1 over 1 over u plus c. And remember, your final answer must be in terms of x, where we want to go back to the original variable of the function, because in question B, we have the function is in terms of x, so we want to go back to the variable x, so negative 1 over, and we know that u, it is equals to 5 plus sine x, so 5 plus sine x plus c. Okay, so this is the final answer for question B. Next, we want to look at a question based on tutorial 4 given in the column. So for this question, if you look here, it is difficult if you want to expand this part, x cubed minus 2 power of 4. Even though it is possible, it is still difficult. You tend to make mistake if you do it. Then an easy option to perform the integration for this particular function is by using substitution technique. Okay, so what we will do, we will let u equals to x cubed minus 2, and from there we will differentiate, where we need to find du dx, where du dx is 3x squared. And if you see here, the result 3x squared is a part of the original function here. Okay? So it gives a clue that our choice of u is most probably correct, but we still have to check later, okay? If you're able to transform this part to a simple integral in terms of u only, that's mean the choice of u that we made here is correct. Okay, so from there, then we need dx, where dx is equals to du over 3x squared. So integration 3x squared times x cubed minus 2 power of 4 dx. Okay, just now we know that this is u. So this is equals to integration 3x squared u power of 4. And we know that dx, is du over 3x squared. So dx is du over 3x squared. And then we can cancel out 3x squared. So what's left is integration u power of 4 du. Ta-da! You get now in terms of u only, where this is a simple integral problem. So this is equal to u power of 4 plus 1 over 4 plus 1 plus c, where this is u power of 5 over 5 plus c. And don't forget, your final answer must be in terms of the original variable of the question, where in this case, your original function given in terms of x. Therefore, we need to give the answer in terms of x, and we know that u is equals to, we have just now u, it is equals to x cubed minus 2. So we will substitute u with x cubed minus 2 power of 5 over 5 plus c. So this is the final answer for question. This is based on question 5 of your tutorial 5A. Okay, next let us look question number 5 also from your tutorial 4, question K. This is a more difficult question. If you see, it looks difficult, but it is not really. If you use the correct technique, it will be easy for you to integrate it. Okay? So what will be our substitution? In this case, we let u equals to e power of x squared minus 1. Okay, we want to take everything here as u. So from there, we can find du dx, where du dx, it is 2x e power of x squared. Okay. If you cannot do, if you cannot get the result from here to here, straightforward like what I did here, then I suggest you to use the substitution technique for differentiation. Okay. Now we are discussing substitution technique for integration, but if you, because in this case we want to find the differentiation first, then if you don't understand why I get from here to here, then you need to use the technique that you have learned in chapter 2. Okay, so from here we get, dx, it is equals to du over 2x e power of x squared. Okay. And then our problem just now, integration x e power of x squared. Okay. I forgot to mention just now, if you see here, a part of this is here. This part is here. So it gives you a clue that your choice of u is correct. Okay. But still we have to look at it later, because sometimes you may see that, oh, it is correct, but it is not. So you have to check first. Dx, e x squared minus 1 dx, it is equals to integration x e x squared. Okay, just now we know that this is u. So u dx is du over 2x e x squared. And from here we can cancel out ex squared, x. So what's left is equal to, okay, we have constant 1 over 2, we factor out, integration u du. Okay. Now we just have in terms of u, where this can be integrated easily, where it is equal to 1 over 2 u power of 2, 1 over 2 u squared over 2 plus c. And this is equals to 1 over 4 u squared plus c. And remember, your final answer must be in terms of x. So we will substitute u. So 1 over 4. Okay, just now we have u equals to e power of x squared minus 1. So we will substitute that. U equals to e power of x squared minus 1 square plus c. Okay, so this is the final answer for question 5K. Okay, one more example. This is also based on tutorial 4, question 5N. Okay, so what will be our choice of u? So we let u equals to 2 plus ln x. Okay. And if you see here, du dx, it is equals to 1 over x, because when we differentiate constant to 0, ln x, we get 1 over x. So if you see here, 1 over x, here we have 1 over x. So it gives a clue that our choice most probably will be correct. So dx it is equals to x times du. So integration 2 plus ln x square over x dx, it is equals to, just now we know that u is equals to 2 plus ln x. So here we can rewrite it as integration u square over x, and then we have just now dx is x du, so dx is x times du. So we can cancel out the variable x. So what's left is integration u square du. Okay, if you see here, now we have everything is in terms of u. So our choice of u just now was correct. And you'll see that from this difficult integral, we come to this simple integral where this can be differentiable. This is differentiable by using the basic formula of integration. Okay, so this is equal to, okay, now we want to integrate it, u cubed over 3 plus c, and don't forget your final answer must be in terms of x. And just now we know that u it is equals to, we know that u is equals to 2 plus ln x, so 2 plus ln x cubed over 3 plus c. So this is the final answer for question 5 and of tutorial 4. Okay, that's all for this lecture video. Bye bye.